Hello students, in this episode I want to talk to you about energy. And in this episode I'm going to demonstrate to you that dollar bill in your wallet represents a storage form of energy. And that energy initially came from the sun. Also, why do brain surgeons make more money than lawn clippings salesmen? I'm going to answer that question for you, so prepare for your mind to be blown. First of all, how do we define energy? That is actually not easy to do. There are many different ways that we use the word energy, but for the purposes of this episode, we will define energy as an essential component of work. Work cannot be done without energy, and work is essentially a product of a mass being moved a distance, and a mass cannot move a distance without energy being involved. In fact, there's a law of gravity that states that a body at rest will stay at rest unless there are forces that act upon it. Mass can even be looked at as resistance to force. For example, I weigh 100 kilograms. If a gnat flies into me, it's not going to really affect me that much. If a 4-ton boulder rolls into me, it's going to affect me. That 4-ton boulder is definitely going to have enough energy to affect my mass. My mass will then move. So even though my mass is inert to forces, proportional to the magnitude of my mass, a greater force can affect it. Likewise, I cannot really affect the boulder if I want to push it away, but I can push a gnat away. So there's definitely an interplay between mass and energy. In fact, you'll find that many of the laws that govern energy also are the exact same laws that govern mass. And that's kind of weird, but if you think about it, there is a famous equation that relates energy and mass. E equals mc squared. If you look at the basic part of that equation, it says E equals m. Energy equals mass. Except you then got to multiply it by this number called c squared. So here's a question for you. Is c squared a big number or a little number? Because if it's a little number, then we could easily say that E is essentially equal to m. So actually that c squared part is the speed of light times the speed of light, which is a huge number to us on Earth. But is it a huge number in the universal sense? Remember, the universe is infinite. So if we look at a number line between 0 and infinity, c squared is actually closer to the 0 than it is to the infinity. In fact, it's almost infinitely closer to 0. Now we know it's not 0 because that would then give us the equation E equals 0. So we know that c squared is something in the universal sense. It's actually a very small number. And that tells us something. It tells us there's a very strong interrelationship, almost equality, between mass and energy. Time for a sidebar. Now, whenever we're using models for thinking, they're always wrong in terms of what reality looks like. And the reason they're wrong in terms of what reality looks like is because when we use models for thinking, we have to control the system in which we are looking at. If you recall, on a previous episode, I talked about an object falling through a tunnel that goes through the center of the Earth from one side to the other. That's to demonstrate how gravity works and how an object would ultimately land at the center of the Earth once it got done losing all of its energy in its falls back and forth from one side of the Earth to the other. In reality, the core of the Earth is molten metal and would obviously incinerate anything even if you were able to theoretically run a tunnel through it. This fact defines the quality of Earth, but if we ignore it, we can look at the quality of gravity. And we talk about energy and mass, we also have to isolate them. And by doing so, we talk about things that are at odds with reality. But it's used to explain the nature of these two entities. End of sidebar. There's a law of energy called the law of conservation of energy that states that energy, although it can be transformed, can be neither created nor destroyed. Energy transformations are important to understand. If I take a gallon of gas, it has a specified amount of energy in it. I run that gasoline through my car engine and it propels me down the road. Keep in mind that car will not move due to the laws of gravity unless a force is applied to it. That force comes from its internal combustion engine, and the energy that comes from the combustion is supplied from the gasoline, which I got from the gas station. So I take the gasoline from the gas station, put it in my car, run it through my engine where it combusts, and that energy from the combustion is translated into motion energy. So every step of the way between combustion and motion, there are transformations of energy taking place. It is important to know that in every step in a transformation process, energy is lost, not destroyed, lost to the process. Lost as heat, lost as incomplete combustion of gasoline, etc. So I will never get a perfect transformation of the energy in gasoline into movement. I will only get a certain percentage, and that percentage is referred to as efficiency. Efficiency of the energy exchange. There is no such thing as a 100% efficient energy exchange. There is always going to be losses. The energy is still there, it's not been destroyed, it's just lost to unusable things. For example, when you drive your car for an hour, you come back home and you feel your engine, it's really hot. And that heat is energy that was lost. You can't get it back, there's nothing you can do about it, it's gone forever. It's not destroyed, it's still there. It's just that it's never to be in a usable form again, most likely. And what about biological energy? If my teacher asks me a question to which I know the answer, I'm going to raise my hand. In order to raise my hand, there has to be a force acted upon my hand because, as we know from laws of gravity, an object at rest will stay at rest unless a force is acted upon it. Before I get the urge to raise my hand, it's being acted upon by gravity and is in a dependent position, either on my desk or on my lap. If I want that hand to be elevated, there is energy that will have to be applied to it. That energy was stored in my muscles, and those muscles contracted, using up the energy which is now lost, not destroyed. And so how did I get the energy to raise my hand? It came from the food I ate. That's why we have to keep eating. If we stop eating, we can't raise our hand in class or live. In fact, if having food is problematic for us, we probably do not have time to spend in class talking about physics. Thank goodness for the agricultural revolution. Without it, we wouldn't have physics. So where did the energy in my food come from? Where did the energy in that gallon of gasoline come from? It came from the sun. In the case of gasoline, gasoline is distilled from petroleum, which comes from the ground. It is produced by plants that lived thousands of years ago. They get buried under the ground and crushed, and the pressure causes them to undergo a process where they just become a large globular mass of carbon. We dig that gloppy stuff out of the ground, and then we distill it to get a lot of different products that we use. One of them is gasoline. As I said, the plants from which oil is made got their energy from the sun in a process that we all know as photosynthesis. It's called photosynthesis because it's using the energy in sunlight to synthesize organic molecules. It synthesizes them out of carbon and oxygen and hydrogen. When those carbon products are combusted, they release energy, which can be utilized to move pistons in an engine, which can then turn a crankshaft, which can then turn a drive shaft, which can then turn the wheels of my car, which propelled me down the road. Those molecules in the gasoline act as a storage form of energy. In the case where raising my hand, that energy also came from the sun, and it came from the food I ate. That bowl of oatmeal I had this morning gained its energy from plants, organic compounds, carbon, hydrogen, and oxygen that I consume. My body then transforms it into useful muscle energy. The amount of energy I have in my muscles is less than the amount of energy I consume due to the translational losses as we talked about. But I did need the oatmeal. I would soon run out of energy and wouldn't be able to live or work. Let's talk about work. The reason I go to work is because it's how I get money that I need to pay for oatmeal. So I use the energy in order to get money that I can buy energy with. And where do I get the money form of energy? It is from a system for which I apply work. I spend my time and energy, and exchange, I get some energy back in a storage form called money. So where did the money come from? It came from the other people applying work and getting a storage form of energy back in return. In the days of bartering, if I wanted to get something, I would work for it, but then I had to find the person that had the thing I wanted who also needed my work. That wasn't very efficient, so money was invented to supplant that. Now, even if I happen to build houses, I can go buy some bread with the money I get from building houses. Even if I build a house for an automobile salesman, I can still buy bread with energy I took from the automobile salesman in exchange for building the house. Now, just like energy is lost during transformations, you generally want to gather some surplus energy in exchange for the energy you provide. Otherwise, it wouldn't be worth it, right? If it cost me $5 a day to do work for which I got paid $4, that would not be worth it. If it cost me $5 a day to do work for which I got paid $150, well, that's a much better exchange. But the energy that I expend comes from the sun. The storage form of energy, money, also comes from the sun. Let's assume I work in a factory, and we know that factories don't exist spontaneously because they're incredibly organized structures that require energy to be constructed. Bulldozers, cranes, dump trucks, those all run on energy from the sun. The iron that came from the metal forge was transformed by energy applied to it, which came from the sun. All the raw products that go into the finished factory to be made into useful objects were able to end up in that factory due to energy from the sun. Because remember, they would have stayed at rest without a force acting upon them. So there's no factory without the sun, there is no work being done at the factory without the sun, and all the energy I expend at the factory came from the sun. The money that the factory has to pay me with came from the sun. It provided products which people paid for with energy they obtained, particularly their surplus energy. The factory then took that energy and gave some of it to me. I'm then able to come to work because I have energy. And if I earn $150 and I need $20 for the week, I get to store the rest of that or use it for something else like a nice TV. That TV exists because of energy that came from the sun. I'm able to purchase it with the energy I expend that came from the sun. That dollar bill came from the sun. A dollar bill came from the surplus energy dug from the ground and turned into factories where I can then expend energy that came from the oatmeal and get oil storage money in return. That's right, I get oil storage money because the primary energy source that we use is oil, which came from the sun. Before oil, there were no skyscrapers, airplanes, ocean liners, all things that require massive amounts of energy and create great amounts of surplus, which we then turn into people. Ah, the circle of life. It's easier to make sense of it if you think of economics as the study of the flow of energy through a system. Let's talk about United States where I live. It's a huge system, huge economy, lots of energy from the sun that we got mainly from oil and coal. If I don't exchange my energy with anybody, then I generally won't get any money. And it's easy to understand how and why money works when you look at it that way. When you see it as a gift that some person decides to give to you or not, you're going to have a really adverse relationship with money. Money has a lot to do with value. How much do you value my work? If I'm a brain surgeon and I remove a brain tumor that's going to harm you, you would probably value that work greatly, probably immeasurably. If I decide that I want to sell you all my excess lawn clippings after I mowed my lawn, you're probably not going to find a lot of value in that. In fact, you might actually not be willing to pay for that at all. It might explain why there's more neurosurgeons than there are lawn clipping salesmen in this country right now. The things that exist that cost money have value, and that's why they're there. Because we all choose how we spend our energy. As the saying goes, it takes money to make money. The saying should be that you have to expend energy to get energy in return. Not understanding that creates all sorts of problems for people in general. So anyway, I hope you enjoyed this. As you can see, energy and mass and gravity are intricately interwoven. Economics is the study of flow of energy through the system, and we use money, which is a storage form of energy that came from petroleum, that came from the sun. And it's better to be a brain surgeon than a lawn clipping salesman.